All right, Basic Food Chemistry. This is Chapter 10, Part 1, and you'll have Part 2. We're going to talk about minerals. So let's get into the characteristics that you find of minerals. One of the biggest things you're going to find is these are going to be inorganic. Okay, so if you talk about things organic, that's carbon-based. That means they burn. So something that is inorganic will not burn. Let's say if you've ever watched a crime show and maybe you find human remains in a building that has burned, and what is left, how they can identify those people is because of their skeleton, and they can do dental records. So what is the big component of those things? That would be things like calcium and phosphorus. Those are minerals. So again, they're inorganic and will not burn. We'd also consider to be ash. So if you see a feed sample or a food sample that's gone through a chemical analysis, it might give you a percent ash, and that would be the total mineral content. So most of these you're going to find in their natural form, whether it's calcium, phosphorus. Some of them you're going to find in a combination together, like salt, as sodium and chlorine. So most commonly required in diets are kind of things what you're going to see here: calcium, phosphorus, sodium, and chlorine together, which make sodium chloride or salt. Magnesium, potassium is K, S is sulfur, I. It's one that confuses people. That is iodine. Fe is iron. Cu is copper. Co is cobalt. Mn is manganese. Zn is zinc. Then you have selenium and molybdenum. Those are the big ones in most diets for humans and animals. So a lot of these are going to be required for skeletal growth, but also some other things, and we're going to talk about them. So some of them may be as a requirement for constituents that make up protein, like phosphorus and or a sulfur. Again, they could be component in fats, certain fatty acids. They make up muscles, blood cells, organs. Some are responsible for maintaining osmotic pressure and establishing acid and base relationships. So sodium and chlorine are big ones for that. But it's really wasteful to fortify any ration or diet with an excessive amount of minerals. And the biggest thing is some of them can be dangerous, some can be toxic. When you're looking at your minerals, the two primary functions are the structural part. Those are dealing with the bones, teeth, tissue, muscle tissue, that kind of stuff. And then we have those that are regulatory. So they're going to control some type of process in the body. So let's talk about our essential minerals. They need to be included in the ration or your diet. So it's provided by most of your normal rations or diets. So sometimes called the macro minerals, essential minerals, just kind of depends. So again, the ones of greatest concern are going to be calcium, phosphorus, sodium, and chlorine. Those are the big ones, with obviously sodium and chlorine making sodium chloride, which is salt. Then of course you got your other minerals talked about. We'll kind of talk about a few of these: iodine, iron, copper, manganese, sulfur, zinc, potassium, cobalt, selenium, molybdenum, magnesium. So first we'll talk about sodium and chlorine together, which we think of, obviously salt is normally what we're going to find in human and animal rations. But the big thing, if you think of one of the first components of when you get to a non-ruminant stomach is, and of course even a ruminant fourth compartment, the abomasum, it contains hydrochloric acid. So that's rich in chlorine. So where does that come from? Obviously with salt, you strip them, basically break them apart. You have the chlorine, you have the hydrogen, which can basically be donated with water, and thus its form. Okay, so there is your symbols for hydrochloric acid. So it's obviously a very essential tool in terms of digestion in the animal and human body. But also we can consider some other components of what sodium and chlorine does inside the body. So for liquids that pass through specific membranes, there's got to be an amount of salt in solutions in liquids on one side has to be higher than the other. So you've ever heard of the term osmosis? That's when you're going from an area of high concentration to low concentration. Okay. And so that's what that is. So that's how we actually get some of these components, very, very small molecular components, out of the small intestines where they can be circulated to the body to be utilized for growth, for reproduction, for energy, whatever it is. Okay. But salt is also a constituent of many tissues, so blood, tears, secretions, sweat, those kind of things. So when you look at pigs, just because they grow quite quickly compared to a lot of other animals, they actually do require a pretty decent amount of salt. For a quarter to half a percent of salt added into their ration. We talk about for cattle. We usually give them free access to salt at all times. That also gives an affinity to consume more water, and that can all be used in fermentation with the bacteria they have in their digestive system. So generally, a typical beef animal will consume about 20 pounds per salt per head per year. So sheep or lambs also have a pretty decent salt requirement. It's about a half a pound of salt per month. Ewes maybe up to a pound. So for their size, it's actually quite a bit higher than a lot of other species. Just kind of give an example, we talk about sweat. Horses that can sweat, or some other species of livestock can't, or not a lot to that extent, but they can lose 30 grains of salt in every pound of perspiration. So depending on if they're a working animal, that can also influence how much salt they need. Think about some, electrolyte sports drinks. They have some sodium in them, and that's again to help with replacing those electrolytes that are removed during work. So with the salt functions, we talked about it, osmotic pressure in cells going, from areas of high concentration to low concentration. That's a big thing. We know it aids in digestion, formation of hydrochloric acid. Those are probably the biggest functions, but again, it could be used in quite a lot of different other areas. So most of the time we think about humans, some people like salt more than others, and so it's usually we think about the taste, whatever tastes good. But it can be a pretty commonly deficient mineral that you do find. So most rations, especially if you look on the livestock side, is pretty important. But even in humans, it's also an important component. But why do we use it as humans? It affects the flavor, so it affects palatability of our feeds. So next we're going to talk about calcium. About 99% of all calcium is in your skeleton, so all your bones, your teeth, those kind of components. But also you think about eggshells. So if I am a producer that is raising eggs to be sold as eggs themselves, having them not break on the way from, the farm or the production area through all the marketing channels into the supermarket and into the consumer's home, with calcium being a big component, I'm definitely worried about calcium in rations for my hens. It also helps a little bit with blood coagulation, working a little bit with vitamin K, which we'll talk about in subsequent chapters. Obviously, it's a big component of milk, so it has a lot to do with lactation. But also, calcium is a very big component. There's a calcium pump that's used in muscle tissue, so for actual muscle function, in terms of contraction, there's a big requirement for calcium. So not only your nervous system muscle function, but also your heart as well. And with phosphorus, about 80% is in the skeleton or teeth, so not as big a component as you find with calcium. But it helps with the assimilation of carbohydrates and fats. It also helps regulate enzyme activity within the body. It's a component of blood tissue. And occasionally we have those types of protein that has a phosphorus and or a sulfur. Again, so it could make a component of protein, so muscle groups. So a lot of time when you look at rations, and especially for livestock, and we can also throw humans into that as well, we're actually looking at balancing calcium and phosphorus. So biggest thing is it does make up about 70% of all the minerals you find in the human or animal body. So we know the importance for skeletal growth, for bone strength, for preventing things like rickets, osteoporosis, osteomalacia, those kind of things, working with vitamin D in that characteristic. So again, we know those percentages, about 99% calcium, 80% of phosphorus are in the bones or teeth. And then the other percentage of phosphorus, soft tissue, enzyme systems, we've mentioned that. And then calcium again, blood clotting, skeletal formation, cardiac rhythm, enzyme action, very, very life-sustaining components that really calcium has a big part in. And then with phosphorus, we know bone, red blood cells, muscle, nerve tissues, again, big components for life. But the biggest thing is you have to be aware in a diet or a ration of how much calcium, how much phosphorus is actually in there, because if you have a large excess of either one, it interferes with the ability of the other one to work or the absorption of the other. So most favorable ratio, you need, again, a ratio of calcium to phosphorus. So for pigs, it's somewhere between, it need to be balanced about 1 to 1, maybe up to 1.5 calcium to 1 phosphorus. And then about 2 to 1 for cattle. So humans, we should have been 1 to 1.5 to 1 range as well, just like pigs, since we have a very similar digestive system. But if you have a deficiency of calcium or phosphorus, for example, in pigs, they've been shown to have a very slowed growth rate, broken bones, posterior paralysis. So again, the mobility and ambulatory action of those animals is definitely decreased. With cattle, you can have lack of appetite, again, lowered growth, inefficient in terms of their feed utilization, decreased milk production. All those things are kind of negative, so again, make sure plenty of calcium and phosphorus is in your diet. So deficiency of either one may impair proper bone formation. It could cause rickets in younger animals or osteomalacia in older animals. So rickets typically where the bones become so brittle that they break, and osteomalacia usually is where they become so pliable that they break. So either one is definitely a negative thing. So where do you find good sources of calcium? Your high quality refuges for livestock, also legumes would have some calcium. So if you eat some like edamame, soybeans, peanuts, those kind of things would have some calcium in them. But the bad things are often pretty low in phosphorus. Things that are a good source of phosphorus, and there's a lot of it. Wheat bran, cereal grains, high protein feeds are good to fare. Then you have like steamed bone meal, calcium phosphate, defluorinated rock phosphate are very excellent sources. So the problem is a lot of things that you'll find out are really high in phosphorus. There's not a lot of things that are really high in calcium. So most of the time for livestock, it's actually about supplementation of calcium to get it at a higher level of calcium than there is for your phosphorus, which needs to be right at or slightly below. So again, monogastric somewhere from 1 to 1.5 to 1. Just want to make sure. And any polygastric, like a ruminant animal, 2 to 1. Okay, ratio of calcium to phosphorus. So here's some feeds that are low in calcium. So we saw just a little bit ago, and you'll see the cereal grains pop its face up again when you see feeds that are high in phosphorus. So your cereal grains, any of those whole grains, those kind of things are going to be really low in calcium. They just don't have a lot. Any grain byproducts, so when they feed distillers grains, those kind of things to cattle, again, not going to have a ton of calcium in them. So things like wheat straw or grass straw, something like that, pretty low. Dried, mature pasture grass, pretty low in calcium. And any plant protein supplement, not going to contain a lot of calcium as well. But those items that have pretty good sources of calcium, any animal protein supplement. So great for humans, not so good when you want to consider feeding animals. But legume forages are pretty rich in calcium, so that's why, again, if you think about a lot of feed yard rations or dairy rations, they would have alfalfa. Well, alfalfa is a legume, so it's actually pretty good in calcium and helps to balance out that ratio. Things that are low in phosphorus would be a dried, mature, non-legume type of forage, and that's about it. Things that are quite high in phosphorus would be like, again, your cereal grains. Here we see it, low in calcium, high in phosphorus. Any of your grain byproducts, pretty good. So distillers grains, DDG, distiller dried grains, and of course most of your protein supplements, because some proteins contain a phosphorus. That's why it's pretty rich in phosphorus. All right, next let's transition to iron and copper, kind of combine those together. Both of them are necessary for formation of hemoglobin. So hemoglobin is the pigment you find in blood. And that heme ring that comes from the iron that's there basically has an affinity for oxygen. So it is what is the carrier for oxygen throughout the circulatory system to take it to every place that it is needed. So again, formation of hemoglobin in red blood cells, but also preventing anemia, which is again lack of iron. So as I mentioned, hemoglobin serves as your carrier for oxygen throughout the entire body. When you look at newborn, young calves, lambs, foals, those type of things, they actually have sufficient amount of iron and copper in the liver until they can actually start eating some food. So they actually have some nutrient value that's stored up that comes from their mother. Problem with baby pigs is they typically do not have enough in their body stores for any type of growth more than about day 10 of life. So that does become an issue. So most people would choose, there's actually a couple of other methods you could use with pigs. Most people would choose an intramuscular injection. It's typically an iron dextran, so an iron sugar, somewhere between 100 and 200 milligrams at about day 2 or 3. And that should be sufficient enough until they really get on some type of food that would have that iron. The second thing I've seen is basically it's an iron dextran in a liquid form and it's in a pump, and you just squirt it in their mouth. But the other thing, there's something out there that contains a ton of iron, and that's soil, dirt. So that's something I used growing up, but most hogs these days are produced on slatted floor, so you throw some dirt in there and it just falls through. Second thing, with pigs being quite susceptible to disease, really worry about bringing dirt from the outside into some type of gestation or a farrowing house. So most of the time they would choose the intramuscular injection. But those pigs that lack iron, they become anemic and they can lose their appetite, become weak, become very inactive. And even if you have a very severe type of anemic reaction, then they might have some heavy breathing, and so it can be called thump because they breathe so hard it actually sounds like a thump. And when you're doing copper, copper is responsible for normal pigmentation of your hair. So think about copper tone sunscreen. It makes sense why it has that name. If you have a deficiency in copper, typically results in rough, bleached, or graying hair coat. Those are some of the things you see. So definitely, if they want to have some shine and some prettiness to your hair, make sure get plenty of copper. So with iron again, make sure we review that. Blood formation was one of the big thing in terms of developing hemoglobin, which is the pigment that does carry oxygen through the body. And so the big deficiency is mostly in your suckling pigs. And again, that deficiency would make them anemic, or it's called anemia. All right, iodine. Iodine gets overlooked quite a bit, and there's a really big reason why it does get well overlooked. So in a lot of areas of the U.S., the United States, there's actually enough iodine in soil that gets transferred into plants. Then that's obviously within that food particle. So for humans consuming and for animals, don't really have to worry about it. But there are some regions of the United States, and if I remember right, it's the southwestern part of the United States, where they don't have enough component in the soil. So it's actually a legal requirement to have a small amount of iodide in salt. And so look at the store when you're buying salt sometime, and you'll see iodized salt. It basically means we're going to add it into that salt for humans and for animals. Okay. So a lot of places they do offer it elsewhere, and it just makes sure that your ration or your diet is fortified with enough iodine. So it's in so many of a quantities that consumption would not be harmful whatsoever. So again, it's a very, very minute quantity, but one of the things that helps form is in the body something called thyroxine. So thyroxine is produced in your thyroid gland in the throat, and that thyroid gland helps control basal metabolic rate within the body, so metabolism, especially when you're starting to break down carbohydrates, is a big one for energy. And again, it's a very, very minor trace mineral, but we do need it for maintaining life. So some iodine deficiencies are out there. One is called goiter, if you've ever heard of that before, which is basically where you have an enlarged thyroid gland. That could lead to hairlessness, and baby pigs could be also a sign of deficiency. I've shown weaknesses in baby horses or foals can come from that too. Next we have magnesium. Magnesium is closely aligned to calcium and phosphorus, so about 65% of that is actually stored in bones and teeth. It's not easily mobilized for any type of usage, so it's typically a permanent storage site for them. But if you have a magnesium deficient diet, it could result in something called hypomagnesia. So some of your clinical signs would be like a loss of appetite, restlessness, nervousness, tetany, convulsions, and if it's severe enough that it can actually cause death. The zinc is also one of those trace minerals. It's a function as a catalyst in hundreds of enzyme systems within the body itself. One of the biggest things, it's going to influence the rate of absorptions of carbohydrates and proteins, so as the amino acid forms from the gastrointestinal tract. If you have a lack of zinc in pigs, it can cause something called parakeratosis, which is a skin condition they can get. But it also, the deficiency can cause impaired growth, depression of certain enzyme actions within the body. So again, you want these livestock to grow. That is a big thing, making sure zinc is fortified. So some factors that kind of combine together to really cause parakeratosis would be, number one, a relatively low amount of zinc in their feed ration, and then you have an increased amount of quantities in calcium and phosphorus in the ration. They all just kind of work negatively on each other. So, and then you have a relatively higher requirement of zinc within pigs themselves. Combine all those things together, and it can cause some pretty severe issues. So the National Research Council will actually recommend that cattle get about 30 parts per million on a dry matter basis in their feed, about 40 parts per million for dairy cattle. Next, talk about selenium. Selenium has a very important relationship with working with vitamin E, and so when we get to the vitamins, we'll talk about vitamin E, that fat-soluble vitamin. And their function is really as an antioxidant, so not only needed by animals and humans, but it also plays not only as an antioxidant role, but a nutritional role too. So I think the biggest component is they are antioxidants. So selenium is definitely essential, but only in very, very, and I mean very minute quantities. So in 1987, the FDA came out with their approved maximum allowance in feed rations, and it is very small, 0.3 parts per million of selenium in complete feed for all farm animals. So, and why? Because excess selenium can be highly toxic. So the chronic form of selenium poisoning is actually called alkalized disease. Those animals' symptoms will be they have a lack of interest in feed or water, and so they don't eat, they don't drink, they become dehydrated. They can actually, in severe cases, start to lose their hair from their mane or their tail, and just all over their body if you get into a pig itself. Then other functions, the hoof will often separate, which will cause lameness. They can actually start to walk on their knees because it's so painful. And then if that continues on to an acute poisoning or a very, very high amount causes acute poisoning, some kind called blind staggers. So that's again when they get a large amount in a short time, and it actually causes sudden death. But before that, they might get impaired vision, lack of coordination, struggling with their breathing process, abdominal pain, and then they die. Problem is there's really no effective treatment for the acute selenium poisoning if you have just a chronic form. Try to get it, figure out what it is in the ration that's causing it. Some other minerals are typically rarely deficient. If there is, it's more about a certain area where crops are grown that become soil deficiencies, and that's where you're going to find those deficiencies. Most of our normal rations are going to contain an adequate amount of minerals. All right, that's the end of Chapter 10, Part 1. So complete the quiz and Canvas and any other assignments, and then you'll have Chapter 10, Part 2.